This is non. See, if you see, you can see that there is no double bond here. If you use DDQ, it forms actually a double bond over here. The mechanism is given before. So this compound is formed. We don't have any double bond earlier here. This can be used to make a double bond over the already enone system. So it forms a dienone system. Now you consider this reaction in which this is the process in which here also we don't have any double bond here. In presence of DDQ, this hydrogen atom, the here from hydrogen here and hydrogen here is removed and it forms a double bond over here. So next reaction is again a typical example of aromatization reaction. You can see that here also when the DDQ acts, it gives off it brings conjugation here, and you can see that you can see that in this case, you can see that here it is a cyclohexatriene compound on treatment with DDQ. It abstracts this proton. You know, there will be H and H. In the first step, it will abstract the proton. Okay, as a result of that, this is hydride is transferred, the carbon atom becomes positive charge. It's called propylene cation, and there is perchloric acid is here, and this perchloric acid does perchlorate ion and forms a salt. It's actually what is called the propylene perchlorate. Okay, propylene perchlorate is formed. You can see that here, if you treat the compound DDQ in perchloric acid, here it is called, this compound is formed. You got a peri-naphthyl cation. We call that to be a peri-naphthyl system. Naphthyl cation is formed. And you can see that here, it forms a peri-naphthyl radical is formed. Thing is that if you use DDQ in presence of perchloric acid and acetic acid gives a cation. If you use DDQ in presence of benzene, it forms a radical, peri-naphthyl radical is formed. Next application is actually oxidation of the allylic position. Oxidation of allylic position. You can see it's a double bond. Double bond, this is the allylic position. This is the allylic position. Okay, allylic position contains OH here. There's already an H also here is there. And you know, in presence of DDQ, the H and this H will go out at minus H2. DDQ takes that hydrogen atom. And as a result of that, a ketone is formed. So alpha beta unsaturated alcohol become alpha beta unsaturated ketone. Here also, you can see that here also same thing happens. Here also, this is the allylic position here. Allylic position, this OH is there and there is hydrogen here. There will be alpha elimination. In fact, these two hydrogen will eliminate and forms a ketone. And here also, you can see this system. This is a allylic position or it's the benzylic position. It's a benzylic position. In the benzylic position, the DDQ acts and it forms a ketone system. The next application is doing deprotection of OH protecting groups. Maybe we'll see this reaction a little bit later when we discuss protecting groups. You can say this is actually a protecting group for alcohol. This OH is replaced by this group. You know what happens is that when you treat DDQ, this bond breaks off and such that we get back the OH. This is actually a protecting group. We can use the compound to deprotect the protecting group. Here also, you can see that this is the protecting group. This DDQ can be used to remove the protecting group. Again, this compound is again a protecting group. This compound can be removed by using, DDQ. The second application of, third application of DDQ. That's all about the applications of DDQ. So DDQ is a very important compound and very useful compound in organic synthesis. Now it's our turn to go to the next compound. Next compound is DCC. Okay, DCC, the compound name is DCC. DCC is actually dicyclohexylcarbodiamide. Dicyclohexylcarbodiamide, DCC. Sometimes also called DCCD and DCCI, but generally it's commonly called as this compound. You know, it's a cyclohexyl group. There are two imide group. Imide is carbon as a double bond is called imide group. There are two imide groups, so it is called diimide group. So there are cyclohexyl. There are two cyclohexyl groups. So we have got the name dicyclohexyl carbodiamide. The name is dicyclohexyl carbodiamide. The compound is DCC, dicyclohexyl carbodiamide. About the property of this compound, it's a very important compound in peptide synthesis. It's a very good dehydrating agent. You can see that it in normal cases exists as white crystals with a sweet odor. Okay, and its melting point is between 30 to 35 degrees Celsius and boiling point is higher than water. This compound is soluble in THF, tetrahydrofuran, acetonitrile, dimethyl-formamide, dichloramidine, etc. But it's insoluble in water. That's the thing. It's insoluble in water, but stable. It's a stable system, but this moisture sensitive, so therefore it's kept in extreme dry conditions. Because in presence of water, it will take the water because it's having a good affinity towards water. So it is called dehydrating. So it is a very good dehydrating agent. It is how we can synthesize the compound. You know, we can start the synthesis from dicyclohexyl urea. Urea, you know, is NH2 C double bond or NH2. It is actually urea. Okay, this urea, one H is replaced by cyclohexyl group here, and one H is replaced by another cyclohexyl group here. So the name is dicyclohexyl urea. So the compound starting compound name is dicyclohexyl urea. This compound treatment with paramethyl tesyl chloride, and in presence of pyridine, in presence of hot pyridine. Pyridine is a strong base, and you know, and also it can abstract water. It can abstract water. So what happens? This two hydrogen atom and the oxygen atom here is removed as water. So the valence is satisfied by double bond here and also double bond here. It forms DCC. This can also be formed from dicyclohexyl thiourea. It is called dicyclohexyl thiourea. This compound possesses of Hg2O. Hg2O is mercurous oxide, Hg2O. So here what happens is that this two hydrogen and the sulfur will go out of H2S. And HGS, and this is taken by Hg. The one Hg takes this, the oxygen is replaced by sulfur here and forms Hg2S and H2O is formed. You see, synthesis of DCC. One of the important application of DCC is in the oxidation. This particular oxidation is called Moffatt oxidation. It's a very important application of DCC. Actually, this oxidation is a peculiar oxidation. First application, Moffatt oxidation. In this oxidation happens generally to the primary and secondary alcohols. So only the primary and secondary alcohols undergo the reaction. Primary and secondary alcohols in presence of DMSO. DMSO is dimethyl sulfoxide, the solvent. Okay, and DCC. There should be two reagents here, DCC and DMSO. They must. There should be DCC and DMSO. What happens is that this compound, a secondary alcohol, is converted to a ketone, and a primary alcohol is converted to an aldehyde. This is called Moffatt oxidation. So, in Moffatt oxidation, primary and secondary alcohols will react with DCC in presence of DMSO. It will give you what? It will give you a aldehyde or a ketone depending upon the substrate that we are using. So using a secondary alcohol, we get a ketone, and if you use the primary alcohol, we will be getting an aldehyde. This is the first application called Moffatt oxidation. Now, the most important application of the DCC is dehydration. So, the dehydration. So, dehydration is actually is the dehydration. Okay, one of the most important application of D is dehydration. So dehydration means removal of water. So this is very vital in peptide synthesis. It is actually very vital in peptide synthesis. So this is actually an amino acid. The amino group, amino is protected by some group. In this compound, the acid is protected as an ester. So we have got a free acid here and free amino group here. So this is an amino acid. So you can see they can combine together. The OH here and the H can combine together to form a peptide bond. So it can combine to form a peptide bond. So for forming the peptide bond, the HOH should be go out. That means water should go out. Then only there is bond formation between the N and CO. Okay, so this can be affected by dehydration, and this can be affected by DCC in dichloromethane. Okay, so it will get peptide, and this actually can again deprotect and combine with another peptide like that. So this can be used for the synthesis of peptide chains, or typically it can be used for synthesis of polypeptides. We can call this synthesis of polypeptides. Generally, they are called proteins. Let us see the mechanism of action of the system. So this is the DCC compound we are having. DCC first gives electron to the free OH of the acid, OH of the acid. As a result of that, what happens is that this will go off and will be having NH plus, and this become O minus. The O become actually O minus. Next step will what happens is that the O minus, the electron rich, we know that what happens, this gives electron to this. Therefore, this nitrogen gets positive. Okay, so what happens? O gives electron to the carbon gives electron to nitrogen. As a result of that, the plus charge in the nitrogen is lost, but there is a new bond formed between the oxygen atom and the carbon atom. So a new bond is formed between the oxygen atom and the carbon atom. So you can see this is the new bond formed between oxygen atom and the carbon atom. Okay. Okay, so in the next step, what happens is that this is the amino, we can call that it's amino acid 1. This is actually amino acid 2. Okay, amino acid form a system like that. The second compound, second amino acid will also interfere with the reaction here. In the amino acid also, there are two lone pairs of electrons. This is the amino acid, second amino acid. Lone pair donates to this bond, ester bond here. And what as a result of that, this nitrogen atom will get a positive charge and the electron is added towards here, and this breaks up. Okay, so as a result of that, it will be coming over here, a new bond is formed, and it gives back the bond by giving off the H plus ion. As a result of that, this is going out and we get the peptide. Okay, it is actually the formation of polypeptide bond. So it actually proceeds by the donation of the lone pair of electron in the nitrogen atom to the COH free amino acid. It forms a salt, in fact, and later it forms a new compound. This compound is when treated with second amino acid, we should have a free amino group that interferes with all the problems here, and it interferes and breaks the molecule and get back the reactants. So another picture of the mechanism. Okay. And next application is, you have seen before, the peptide formation. Next, third application of the compound is formation of esters. Formation of esters. Esters which are difficult to make can be synthesized by using DCC. This is actually COH, free COH. This is tertiary butyl alcohol. Tertiary butyl alcohol, it is a sterically hindered alcohol. Normally, it will not undergo esterification, but it must DCC is a strong dehydrating agent. So the OH here and the OH here will eliminate together and forms the salt. Here you can see that it is actually a very complex system in which there is COH here is that here, and you can see that here is OH is there. You can see that this H, COH and this OH, they can combine together to form a variety of compounds. This paper is also reported in Organic Letters in 2000. The early paper supported in Journal of Organic Chemistry, GOC, in 2001. You can see that here you get a variety of big compounds. Actually, it's very simple if you understand the reaction, in fact. Next one is actually lactone formation of lactone. So here we can see this is a compound in which we have got OH and COH are in the same atom. OH and COH are in the same atom. So here we react that with DCC. What happens is that the OH here and the OH of here and the H of the alcohol, they get removed of water and it forms the lactone. Lactone is cyclic esters. It forms the lactone. Similarly, in this compound, you can see that here also there is OH here and the COH here. In presence of DCC, this OH and this H will be going out. Okay, and this particular compound is formed. Okay, and you can see this is again another example. Here also we have got OH and COH. It forms a lactone system. Lactone. So also it is actually a lactone. Here also it forms a lactone. So the next application is lactone formation. The fourth application is lactone formation. Next one is the formation of anhydrates. You can see these are two acids, RCOH. This is RCOH. These are two acids. The two acids on reaction with DCC, it is a good dehydrating agent. It triggers elimination of water. So the OH and this H here, it eliminates water and it forms an anhydrate. So it's sulfonic acid. So benzene sulfonic acid. So it forms benzene sulfonyl anhydrate is formed. Here you can see COH and COH. So in presence of DCC, they can give removal of water and forms this peculiar system. Next application is dehydrative coupling. Next application of DCC is dehydrative coupling. Dehydrative coupling means we have got two aromatic acids here, ARCOH. There is hydrogen peroxide in between, HOOH. This is another molecule of organic acid. Okay, here what happens is that the OH of H and this H will go out as water. And you can see this H and this OH will go out as water. As a result of that, a new peroxide bond is here. So it forms as a result of it forms what? C double bond O, keto, this C double bond O. And here there is either linkage, OO linkage, and you can see that air. It's called peroxide bond. It's called peroxo linkage. It's a very rare compound to form. Again, this is a phenol, this is an alcohol. In presence of DCC, what happens is that here there will be H and OH will be going here. It forms AROR. It can form ethers. This can form here thioethers. Another application of DCC is the dehydration to form nitriles or acids. Cyanides. It's an oxide. It's an oxide. Oxymon dehydration. That means here the OH from here and there's H over here. The H and this OH get removed of water and it forms cyanide. So that's all about the application of DCC. Here so we have seen Moffatt oxidation as one of the application, peptide synthesis, ester synthesis. And we have seen the formation of anhydrates, formation of nitriles, dehydrative coupling, and everything. Formation, everything is lactone. Formation lactone is here, and there's a lot of applications for this dehydrogenated. So thus we finished two compounds. One is DDQ and one is DCC in the today's section. Thanks for the patient listening.